This video is about dilations. So we'll be looking at some of the characteristics of dilations as well as performing a dilation in this video. So the first thing about dilations is the definition. Okay, so a dilation is transforming a shape by keeping its size proportional and angles congruent. Okay, so dilation is transforming a shape by keeping its sides proportional and angles congruent. So by proportional, okay, that means you have a scale factor. Okay, so scale factor multiplies or divides. I cannot stress this enough. Okay, multiplies or divides. On test 5, this was a question that I thought was going to be a slam dunk, but a number of us still missed it, as well as on the corrections. So we need to know that a scale factor multiplies or divides. The preimage to get to the image. Okay, so our scale factor will multiply or divide. Multiply or divide. Now, if we recall, we have our scale factor is k. Okay, so we have that k value, and then preimage to image. Okay, so we're going to make a little chart here. So if k is between 1 and 0, that means the preimage is bigger. If k equals 1, they're the same size. And if k is greater than 1, then the image is bigger. Okay? So this hopefully makes sense, because if we are between 0 and 1, that means that it's going to be multiplied by something less than 1, so it gets smaller. K equals 1, it stays the same. And if k is greater than 1, we might do something like doubling or tripling in size. Okay, so we're going to go ahead and perform a dilation. Okay. Okay, let's go 1, 2. And let's say we'll go here. So here's our triangle. A, B, C. Okay, so we're going to dilate about 1 comma negative 1 by 1/2. Okay, so our center of dilation is 1, negative 1. So what we're going to do here is we're going to look at the distance between all of our points and our center of dilation and multiply them by 1/2. Okay, so for point A, we go down 1, 2, 3. Okay, so instead we should be going down half of that. So A prime is going to be at 1/2 or 1.5 below our center of dilation. So there's A prime. B, so B goes down 1 over 2. So we're going to go half of that, which is down half over 1. There's B prime. And then C. C goes from the center of dilation, 1, 2, 3, 4, 1, 2, 3. Okay, so we're going to go half of that, so that'll be 1, 2, and 1.5. So there's C prime. Okay, so it's kind of a bit hard to see there, but a couple things. First off, we labeled ours with A prime, B prime, C prime. And second, our pre-image is bigger than our image because our K is 1/2. Thirdly, if we draw dashed lines between the center of dilation, or between the image and pre-image, we're going to hit that center of dilation. Okay? Notice how all three of those pairs, we can go from A to A prime to the center of dilation. C to C prime, center of dilation. B to B prime, center of dilation. I have a couple of questions to answer regarding dilation.